Hi everyone, this is Kamrul. Now I am going to my research paper presentation. Discuss about my research paper presentation. My research paper presentation is a study examining relationship between microfetan and security vulnerabilities. The contents: what is the core contribution of this research paper? Problem the author address, solution of the problems, method of the solution, how the solution is experimented, the new findings from the research paper, and limitation of the work. The contribution of the research paper: we analyze the distribution of microfetan is vulnerable classes and classes where no vulnerabilities have been reported. Our comparative analysis on the distribution of microfetan will discriminate among the microfetan regarding their effect on making a class vulnerable. This will assist the developer to be more restrictive in the uses of the microfetan as well as guide them to inspect their code for potential vulnerability. The finding of the study will help tester become more focused on the potentiality vulnerable area of code instead of the entire code base. It will definitely save time and effort of the tester and ensure efficient testing for the suspected code. And another contribution, our vulnerability study at the class level will help the developers to concentrate at the lower granularity level of code and pinpoint the vulnerable components more easily. This analysis will develop a good understanding of secure code among the developers. They will be able to ensure reliable system evaluation by the re-engineering. The later version will the proper uses of this code construct. The last contribution of this research paper is this study is foundation for developing a security matrix using this pattern and building an effective prediction model along with other code level security metrics. Which problems indicate from the author address in this research paper? Is there any significant difference is microfetan's distributions between vulnerable and non-vulnerable classes? How are the microfetan related to different type of vulnerabilities? How do the microfetan evolve vulnerable classes to non-vulnerable classes? The last, how are the microfetan associated with each other is vulnerable and non-vulnerable code? The solution of this problem, which addressed by research paper. There are four problem indicated. The first problem: is there any significant difference in microfetan's distribution between vulnerable and non-vulnerable classes? The solution from the author, like this question will establish the relationship between microfetan and vulnerabilities. We explore the distribution of microfetan in both vulnerable and non-vulnerable code. This analysis will help us to determine if two distributions are significantly different from each other. Thus, the statistically significant difference is the presence of microfetan in vulnerable code and non-vulnerable code indicate their high correction to the respective code. The second question is, how are the microfetan related to different type of vulnerabilities? The solution of this problem, the answer to this question explores if the distribution of microfetan vary with the types of vulnerabilities in the code. If we find statistically significant difference in microfetan's distribution for the different type of vulnerabilities including denial of service and information disclosed, we will be able to classify the vulnerability type based on the microfetan's distribution. The third question from the research paper is, how do the microfetan evolve from the vulnerable classes to non-vulnerable classes? The solution perspective from this question. These questions are to state the relationship between fetan and vulnerabilities indicated through question 1. For example, if we see that microfetan A is the frequent is in vulnerable classes and microfetan B is the frequent in non-vulnerable classes, and we get the evaluation type A if then B, this result state and the claim that fetan A is more vulnerability prone than fetan B. And the third question is, How are the microfetan associated with each other in vulnerable and non-vulnerable code? The solution from this perspective of problem: to answer this research question, we examine the microfetan data for vulnerable and non-vulnerable classes to get the phi coefficient for each pair of microfetan. In case of both the vulnerable and non-vulnerable classes, we find the pair of microfetan where the association is high or medium. This analysis helps us to determine the joint effect of microfetan on vulnerability generation. For example, if we see the compound box immutable is highly associated pair in affected classes, whereas they have no association is non-affected classes, we can conclude that their joint occurrence has some effect on making the class vulnerable. We can solve this problem by using 6 steps: follow. First, system detection, and second, tool selection, and third, data collection, and fourth, data extraction, and fifth, data analysis, and lastly, we can get result or output. We can mention a chart for easily understand a solution, like as we can firstly start and then collection last affected version, and then collection valuable classes, and then get from archive FRC Tomcat archive, and then affected and non-affected class, and then step extract microfetan. After completed extract microfetan, we can start microfetan and then analysis data and get the output or int. We find out the more limitation of this work, like construct validity, external validity, and internal validity. What is the construct validity? Construct validity refers to a degree to which a test measure what is claimed or purport to be measuring. In this study, microfetan are defined based on the formal condition of the structure of a Java class, and this pattern may not be enough to consider all type of characteristics a class may have. The vulnerable classes were found from the FRC Tomcat project vulnerability report. We also define the last version of its release as non-vulnerable to compare the distribution of microfetan in vulnerable versus non-vulnerable classes. But the effect is the classes that were considered as non-vulnerable may be reported as vulnerable in a later release. Moreover, for the second case study, we assume some classes to be non-affected as detected by ESBD, which may result in some false negatives. Another limitation of this work, external validity. What is the external validity? External validity refers to the ability to generalize result. The experiment was conducted on 4 systems, including FRC Tomcat and 3 vulnerable web applications. As microfetan are defined only for classes and vulnerability data is not well-formed for other Java projects, we limited this study to this application. So it cannot be concluded that the results are valid for other systems written in different programming languages or different frameworks. The last limitation to find out from the work, like internal validity. What is the internal validity? This thread refers to the possibility of having unwanted or unanticipated relationship. We are not claiming the caution, just rating software vulnerabilities with the presence of microfetan. We do not claim that the suspected microfetan are the cause of the vulnerability finance of the classes, but we recommended rigorous testing of the classes containing those microfetan. On the other hand, we encourage the use of microfetan that seem to be more frequent in the more vulnerable classes, although it cannot be claimed that the class with this microfetan will never be susceptible to vulnerability. But we can at least declare that the class with these patterns will not need rigorous testing compared to the classes with other microfetan. In addition, for the question, research question 3, we ignored the change of microfetan in other version between the affected version and non-affected version, which may have an impact on the result of the study. Thank you, everyone.